Thanks. Good afternoon all. I hope you can, the coffee is still working. I work for a company called Mendix, and we were founded in the Netherlands. And we built an application studio with which you can build enterprise applications. And consultancy firms like Capgemini are using the studio to build applications for really large enterprises like banks and insurance companies. So we're basically building software for software developers, and that's cool. And today I'm here to convince you that state management is easy. And maybe at a moment you might think otherwise, but really it is. I mean, once the DOM was a hard thing, and we couldn't get any event listener working consistently across browsers, but at least we could spend a lot of time by looking at the toolbars. But those things have largely been solved. I mean, the DOM has been standardized, and we have excellent libraries on top of it, like React. So, time for a new challenge. And that's one of those new challenges is state management. There's a lot of discussions, and there were those flux wars. And we cannot talk about state management in React land without talking about Redux. I mean, Redux is like the most well-known and second best state management framework around. So a Redux is like a bicycle. And here at the Netherlands, we really love bicycles. Somebody almost killed Joshua yesterday using a bicycle. And bicycles are really simple and elegant, and we can understand them by just looking at them. And that's why we love them. We only need a 50mm wrench to maintain them. So that's really cool. And actually they can do all kind of cool tricks. Well, with Redux, for example, you can play straight forward and backward, and it's really convenient. But as it turns out, and what you hear people also complain about, is that although the concept is very elegant and simple, you need to put lots and lots of abstractions on top of it, and so it starts to pile up. You might wonder, is that a bad thing? Well, of course not, because it's an opportunity to learn new things. So I can recommend everybody to learn Redux. It will give you big insights. But sometimes you just want to get things done. Sometimes you just need a moped, so that you don't need to do all the pedaling yourself. And really cool, I will be talking about MobX today, and it's built in the Netherlands. So it's like a home game. And MobX is quite cool. People are enthusiastic about it. And this is what some guy on the internet said about it. So it must have something. I think I'm gonna convince you of that today. So I will be talking about the idea and how MobX makes state management simple, how it makes it fast, and how it makes it scalable. And so first, to get the idea of MobX, we have to understand the philosophy. We have to know why we consider state management to be hard. And so actually I think that state management is not that hard. I mean, state is a bunch of data that describes your application. It's usually domain specific, maybe some UI state sprinkled on top of it. And it's just a bunch of collection of objects, lists, maybe some references. And we need to do some verification of input and make sure that it stays consistent internally. But in principle, it's not all that hard. The problem with state management is that what happens when state changes? How does that affect our application? And changing state usually has a lot of effects. And when we need to deal with these effects, when we need to consider what will happen if I change state to all those things, that is where it gets complex. So maybe we need to update some aggregated values, like a shopping cart, or we need to update some lookup tables, or we need to send the changed data to the server, or we have to update UI, like our React components to DOM. And actually, James had this morning also a very nice example of it. Maybe you need to change the URL of your browser if the state changes. Maybe you changed selection and then you need a new URL. And all those things at the bottom are all things that react to your state. And those are the things that make it hard. So if we could just prevent needing to reason about the bottom part, state management would be simple again. And that is the whole idea of MobX. Just reason about your state. Make it as small as possible. Don't allow any redundancy in your state. Because as soon as you need redundancy, then you need to update stuff in two places. And then it's hard for somebody to join your project and reason about what needs to happen. But if he can join your project and just know that he can safely change your state without caring about the effects of that, then state management is simple. But of course, the effects need to happen. We need those, otherwise we don't have a working application. So we need to make sure somehow that all those effects can be derived from your state, and they can happen automatically, and that they happen always consistently, and that they also happen efficiently. Otherwise, it has no use. And these are the things that MobX ensures. So the architectural diagram of this whole concept is really simple. You have state, and actions affect your state. And from there on, MobX ensures that everything that needs to react to your state does so. So let me first explain you how it is simple. So this is the tree of all state objects which are tracked by a component. And it's like that system creates a connect function on the fly for you. So it observes the avatar and the name and two tags. So the interesting question is, how did you do that? What did I have to write for that? So here's some of the code behind it, this time in ES6. But as I said, it works also on ES5. And again, I just decorated all the properties to indicate to MobX that these pieces of data form the state of my application. And also very important, I marked the display name of the user, which combines some other attributes, as being computed. Because a thing like a display name should never be in the state, because it can be derived from the state. And as soon as you put it in the state, then you would be able to create inconsistent state. And that's what we want to prevent at all times. And it doesn't just work for primitive values. We also have an object with picture data, and we also have, is my mouse visible? Yes, it is. An array with tags, and those tags can just contain real references to real tag objects. You don't have to normalize it or something. It just works fine by using references. So what does the component look like? This is the component of the contact in the sidebar, and it's really straightforward. So we change the class name for the background depending on the selection, and when you click it, we say that it should be selected, and we just simply map over the tags and push them to some other components. We can safely do that because the data isn't normalized, so we have real tag objects available here. And the only thing we needed to do is just decorate this stateless function component with observer. And from there on, it did all the optimizations itself, like rendering the tags automatically and tracking that deeply. And the context overview is also very similar. And there's one feature in there which I didn't show you yet, but you can click a button to create a new user. And I'll just show you it. It uses the random user API, which is available on the internet, so I hope it's online. And so it added it, and you saw the spinner. You can click it another time, or 3 times. And it also updates automatically and removes the spinner. And so the only thing we need to do to that is to track how many requests we have currently running. And if that's more than 0, then we show the spinner, and otherwise we hide it. And so what does that create random contact action look like? Well, it's really straightforward. There's even not any MobX stuff involved here. We just, as said, increase the number of requests which are pending so that we can use it in the UI. We call the API, create a new contact, push it on some array, and then we're done. And so the system determines itself how this has affected the UI. And it might be that you change the UI and it doesn't even affect the UI at all. It's all determined at runtime. And so basically you've seen everything which is essential API of MobX. And you know already enough of it to build very decent applications. So that's basically all you need to know. Of course, you might be wondering, if it is doing all this stuff, will it be fast? If it does all these things automatically, and if I don't optimize it. So to figure it out, I've built a small benchmark. And that benchmark uses the to-do MVC example from Redux. It's like a textbook example. And I've run 3 scenarios on it. One is, given that you have 1,000 to-do items, change one. Same scenario, given 10,000 to-do items. And you might be wondering, nobody is ever going to render 10,000 to-do items, which is of course true. It doesn't make sense. But if you are building visualizations, then it's very easy to have thousands of components going on in your visualization. And if you then want to have drag and drop experience, then you have to really fast rendering, and then those numbers really matter. And so when you have 1,000 to-do items and you change one, it takes roughly 80 milliseconds to update the UI and update the state. And if you increase the number of, if you increase the state size, then that number really goes down. And having 10,000 items and then adding another one, then it takes the UI 2 seconds to process all that. So that really went off the chart. And then Abramov saw this number because I shared it on Twitter. And so he chimed in and he made the example a little bit less textbook-like. And he applied a number of optimizations, for example, by storing the list of to-dos which need to be shown and the list and the to-dos themselves separately. And so that really improved performance. So that made it really acceptable. But it also shows that it matters much how you organize your state tree in terms of performance. So it's like we're losing some separation of concerns if UI is affected by how I build up my state tree. And of course, the whole point was to compare it with MobX, with also a naive out-of-the-box approach. And that's basically yielded the same results as the optimized Redux example. So I think that makes clear that it is fast. And you might be wondering, how can it be fast? Because you're using all those mutable data structures and such. And there are two important aspects to that. First of all, it's very fine-grained tracks, and you saw that in the dependency tree. It tracks very fine-grained which pieces of data are relevant for a certain component. And you can imagine that that results in a dependency tree between computations and the state. And when you have the tree, you can do lots of interesting analysis with it, so that you can order computations in the right order so that you don't have to run them twice if they are dependent on each other, those kinds of things. And it also uses a pure render mixin. And usually people are like, what? Pure render mixin is for immutable data. How does it work with mutable data? That's a fun story. It doesn't fit in my presentation, but feel free to ask me afterwards. And finally, is MobX scalable? Or in other words, how do we use it at Mendix? At Mendix, we have a very complex domain we work with. We have even a formalized language to express our own domain. And we also have an SDK which is publicly available for that. And it looks a bit like this. These are the modules. And in those modules, there are classes, many of them. And all those classes have attributes and references to each other and inheritance going on. And nobody knows this domain by head. It's too big. So that gives a bit feeling of the impression of the complexity of our domain. And that whole domain is powered by MobX in our SDK. And what we do, for example, is that we build visualizations on top of that. And here is one. And this is quite a big canvas, and it's sadly not in WebGL. It's with SVG and DOM. That's because it's for most of our representations. It's important to be able to select text and copy, paste things, and those kind of things. So that's why I think this is a very scalable approach, because you have you try to find a minimal state that describes your application. And once you do that, and makes it really easy for other people to jump onto that application, because they can just work with the state and change it without needing to know what all other things they would need it to do to make it properly work. And it's also scalable because this really big domain, we don't need to normalize it. We can just have references all running around, and that's programmed very conveniently because you can just walk all the references. And it results in really simple code. And what is also nice about that is it allows for some architectural freedom. So you can do this in a very MVC-like manner, but you can also do this in a Flux manner where you use actions and dispatchers and put all your logic in there. It's really up to the developer again to figure out how he can best structure his application. And finally, and I think that's a pretty cool story, we didn't build that SDK not just for ourselves. We also have partner companies using that very same SDK. And we never even told them that it is using MobX. We just gave them the API. These are the classes. Feel free to change the data in any way you find convenient, because we are sure that all the changes you make are picked up, that the changes are sent to our backends, that UI is updated. And also we have third parties which work from the other side. They just build visualizations on our state model. And they also don't need to know about MobX, because we can just grab their components, wrap them with that observer function call, and then we know for sure that their views will react whenever somebody else changes the state. So I hope that convinces you that state management is simple again. And there are some testimonials over here who are using it already in production. You can ask them probably as well. And it's time for questions, I guess.
Thank you. Thank you.